Today we're going to be talking about conditional probability, and specifically it relates to the tree diagram at the bottom after the questions. So we have this data with tree diagrams, data or probability, whichever you prefer, and it's concerning the prevalence of an STD in a population and the test results. Now here, 10% of the population has this STD. 90% does not. Okay, so that's represented in the first little branch here. Now the end branch or leaves of this tree are the test result. So for an individual that does have the STD 95% of the time, the test result is positive and correct. 5% of the time it gets it wrong and it's negative. Okay. For individuals who do not have the STD, which is the majority of the population, the test confirms that they do not have the STD 80% of the time, but 25% of the time it makes a false positive. That is someone who does not have the STD. The test says it does. So we're asked to calculate these probabilities based on these tree diagrams. Now, one thing that I'm going to point out quickly here is notice that the 95%, that is a conditional probability. We're conditioning on the fact that the individual does have the STD, and that 95% represents the probability the individual tests positive if they have the STD. Okay, so this tree diagram lists conditional probabilities and prevalences. Let's answer these questions. So the probability of an STD and a positive test result, well, we're going to use the conditional probability formula. This is the probability of STD times the probability they test positive given they have the STD. Now, the probability of STD, that's 10%, 0.1, times by the probability of a positive test for an individual that has an STD, that's 0.95. Okay, so this is 0.095 or 9.5%. Okay. 2, or I guess 2, I went to numeric things here, so A, B, and C. I'll change that to a 1. 2, what's the probability the test is positive? Now, there's two ways for a positive test result. That is the probability of an STD and a positive test result. We just calculated that above. Or no STD and a positive result. Okay, so we have this or, that's the general addition rule. Notice you can't have both. You can't have no STD and an STD at the same time. So this just adds because they're disjoint outcomes. So this is STD and positive plus probability of no STD and positive. Now this first one we calculate as 0.095. The other one is a conditional probability formula, and it works exactly the same way. It would be the probability of no STD times the probability of testing positive given no STD. And when you do that, that'll be 0.9 times by 0.2. Okay, and you notice, hey, that's just multiplying along the path to get positive there. And similarly for STD and positive. Okay, so that's one shorthand. When you have a tree diagram, you have to make the diagram to get these probabilities. Okay. Now, we need to multiply and add these. This will be 0.095 plus 0.18. So that is a 27.5% chance, or 0.275. Okay. Now, let's do this third question. Now, this is an interesting one. You know, you get your test results, but the truth of the matter of if you do or do not have the STD is unknown, because there's two ways that you can test positive. You can have it or you cannot have it, right? So that is, you could be a true positive or you could be a false positive. So probability that you see a positive test result, or excuse me, probability, the question here will be probability that you have the disease given the test is positive. Okay. So, in general, if you're the medical professional or the person devising this test, you know, you're hoping that this is a high probability because you want to be able to identify individuals with the STD. And, this is an issue that even plagued companies like Theranos, who, went out of business. Okay, so we're going to use the conditional probability formula. This will be probability of STD and positive divided by the probability of the given information, which is that the test is positive. How convenient that we calculated the probability the test is positive before. That's 0.275. We also calculated the probability of STD and positive. That's 0.095. And this gives us the following probability. It's 0.345, about 35% chance that you do in fact have the STD. Okay. I'll just point out that things like this, true positives, false positives, they became very important during the time of COVID testing and are a current medical issue in all types of identification or diseases. Thank you very much.